Howdy, this is Algebra 2, Section 5-7, the binomial theorem. The binomial theorem. I bet it's a theorem about binomials. It is a math idea about binomials. So, 5-7, the binomial theorem. Section 5-7, the binomial theorem. What the binomial theorem does is it helps us to take binomials to certain powers. We're going to have one example here. So let me go ahead and write that first. This is what we want to do. 4x minus 3 to the fourth power. And what this means is it means 4x minus 3 times 4x minus 3 times 4x minus 3 times 4x minus 3. 4 of those. Then we'd have to FOIL the first two and FOIL the second two and then multiply all of it together. The binomial theorem says that when you take a binomial to a power, this is the easy way to do it. What we need to do first is draw something called Pascal's triangle. I'll do this over to the right here. So Pascal's triangle starts with a 1, and then underneath it you write a 1, and it has a 1 on all the outsides. On the inside numbers are the sum, the addition of the numbers above it. So if I say, well, what's 1 plus 1? Well, that's 2. And these are going to be staggered. This isn't like an Excel spreadsheet with one number right under the next. They'll always be off to the side. There'll be one in between each. So let's add 1 here and 1 here. It's kind of like 1 plus 0 there as well. So here, in between 1 and 2, here I'll write 3 because 1 plus 2 is 3. And in between 2 and 1, 2 plus 1 is 3. Again, with the 1s on the outsides, we'll draw a couple more rows. 1 and 3 gives me 4. 3 and 3 gives me 6. 3 and 1 gives me 4. Okay, so I'm adding the numbers. We get one more row here. Maybe we'll have to add to it later. I don't know. 4 and 1 is 5. Let me see. 4 and 6 is 10. 6 and 4 is 10. 4 and 1 is 5. And this will continue on forever and ever and ever, and I'll show you a web page in a little bit that'll make it as big as you would like. So we're going to use this to solve this problem. But how in the world would this help us do this? Well, let me show you. The first thing we need to do is locate the correct row. Okay, and the correct row is whatever. I want the second number to match my exponent. So this is the correct row for this exponent. If this was to the third power, I would use this row instead. So this matches that. So what I'm going to do first is I'm going to write each of these numbers down. And I'm going to do this vertically. I used to do it a different way, but I think vertically works better. Let me try my red here. Is this a pinkish color? I don't know. Let's see. Oh, pink. Oh, well. So 1, 4, 6, 4, 1. We're going to write all of these numbers out here, but vertically. And most people will write it out just across, but I think it's a little easier to see where to put stuff if you do this vertically. Let's use parentheses. I'm going to need 2 sets of parentheses. Okay, and again, you're probably wondering, why are you doing all this? Just play along, okay? On the first, I'm going to start with 4. 4, 3, 2, 1, 0. This is an exponent. And then 0, 1, 2, 3, 4. Okay, again, it's kind of weird, but it's a pretty simple pattern, right? 4 down to 0 and 4 down to 0. And then write the 2 pieces of the binomial in those parentheses. So first I have 4x, then I have negative 3. So 4x and negative 3, 4x and negative 3, 4x and negative 3, 4x and negative 3, 4x and negative 3. And believe it or not, this is your answer. We just need to simplify it. So let me go ahead and start writing out my answer. Okay, anything to the 0 power is 1, so that's going to go away. So anything to the 0 power is 1. Let me get rid of both of those. Okay, and this is my first term, 1 times 4x to the 4th power. So 1 times 4x to the 4th power. Well, what is 4x to the 4th power? 4 times 4 to the 4th power. 4 to the 4th power. I can use my calculator to help me with the numbers a little bit. 4 to the 4th power is 256. And then this will be x to the 4th. So my first term is 256 x to the 4th. Okay, it's times 1, so that's not going to change anything. 4 to the 4th power is 256. X to the 4th power is x to the 4th power. So that's my first term. I've got that one taken care of. Let me check them off as I go. And when I write my answer, I'm going to do it across here. Okay, so the next line, I need to simplify this. Well, let's see. It's going to be, let me just look at the numbers here. Okay, so 4 times 4 to the 3rd. So what I'm doing is I'm doing this, but just, hang on, times -3 to the 1st. And I didn't really need to write that to the 1st there, so let's not do that. So what I did is I wrote this out without the x, because the x I will write later. So the coefficient, let me hit enter here, it'll be -768. -768. Okay, and then it's going to be x to the 3rd power. So whatever the x is, I just copy it from right there. So let's do this here. Okay, let's see, 6. Whoops, and we got that one taken care of. Let me check those off as I go. So the next term is this, 6 times 4x squared times -3 squared. Well, 6 times 4 squared, I know that's 16, but I wrote it anyway, times -3. Whoops, negative, not point, -3 squared. Okay, and by writing it this way, the -3 is squared. If I didn't put the parentheses around the -3, it wouldn't evaluate correctly. Okay, it would take 3 squared and then make it negative. Now, again, I could have just written 8 here because I know 4 squared is, oh, no, sorry, 16, because I know 4 squared is 16. And I could have just written 9 here because I know -3 times -3 is 9. But I went ahead and did it just like that anyway. So next is 864. 864. That's a terrible 8. I'm embarrassed and ashamed of it. But that one's done and over with, so let's move on. The next line. Now what I can do, I can hit second and enter, and that will bring up the last line, and then you can just edit it. Okay, so it is 4 to the, let me see, 4 to start, and then 4x to the 1st. Well, that seems kind of silly, kind of 4 to the 1st is 1, and -3 cubed. Okay, so -432 is next. Minus 432, and I'm getting, there's just a lot going on here. So this was x squared in the previous one, and minus 432, well, that's going to be just a plain x. Choo. Okay, finally the last line, 1 times -3 to the 4th power. -3 to the 4th power. I think that's 81, right? -3, whoops, to the 4th power. Yeah, 81. Okay, plus 81. Okay, so if I took 4x minus 3 to the 4th power, if I wrote 4x minus 3 times 4x minus 3 times 4x minus 3 times 4x minus 3, and then I FOILed or multiplied and did all that stuff, I would get this for my answer. I would get 256x to the 4th minus 768x cubed, and so on and so forth. I would get that in the end. Okay, so that is the binomial theorem. I could do another example, but it'd be exactly like that. They're all exactly like that. They're no different. They are exactly like this, except if you have, the 4x goes and then whatever's there, you just might use a different row if there's a different number of numbers. So if this was to the 5th power, I would have used this row right here. Okay, now let me check that off too. It just looks incomplete. So those are my notes for you on the binomial theorem. I can get them all on the same page even. It's just weird. There's, yeah, anyway. Yeah, cool.